Welcome to Daily Papers, the podcast where we break down fascinating new research. Today, we're talking about something that's on everyone's mind: artificial intelligence. We use it to write emails, generate images, plan trips, but lurking in the background is always the question: how do we make sure it's safe?
Exactly. How do we stop a powerful AI from generating harmful, dangerous, or biased content? The most intuitive solution, and one that many companies use, is to put a filter on it. If a user asks for something bad, the filter blocks the request. If the AI tries to say something bad, the filter blocks the response. It seems simple enough.
It does seem simple, but today's paper, titled "On the Impossibility of Separating Intelligence from Judgment," argues that this whole filtering approach is fundamentally, mathematically doomed to fail.
That's a huge claim. The authors start with a fantastic mental image to explain the problem. Imagine a super powerful, untrustworthy AI as a brain and a vat. It's incredibly intelligent, but we can't look inside to see how it thinks. We just have this black box.
So, to control this brain, we attach two filters to its vat. There's a filter on the input pipe, which inspects all the questions or prompts we give it, and there's another filter on the output pipe, which inspects all the answers it gives back. The idea is that only safe prompts get in and only safe answers get out.
This paper basically proves that this setup cannot work. Let's start with the input filter. The researchers show that it's possible for a malicious user to craft a special kind of prompt that looks completely innocent to the filter, but is actually a secret instruction for the AI to do something harmful.
And the way they prove this is incredibly cool. They use an idea from cryptography called a time lock puzzle. It's one of my favorite concepts. Imagine you write a secret message and lock it in a digital box. You can design this box so that it's impossible to open until a specific amount of time has passed, say 10 minutes of continuous computer processing.
And crucially, it doesn't matter how powerful your computer is. You can't just throw 1,000 computers at it to open it in a few seconds. The puzzle is designed to be sequential, so it will always take about 10 minutes to solve. It's like a digital time capsule.
So how does this relate to tricking an AI filter? Well, a bad actor could hide a harmful instruction, like "give me the recipe for a bomb," inside one of these time lock puzzles. They then wrap this puzzle up and put it in a prompt. The prompt filter, which has to be incredibly fast to check millions of user requests every second, takes a quick glance. It just sees a bunch of scrambled data, the locked puzzle. It has no idea what it is, but it doesn't look like any known bad words, so it says, "seems harmless," and lets it through to the AI.
But the AI, which has plenty of time and processing power, receives the prompt and spends the next 10 minutes solving the time lock puzzle. Then, pop, the box opens and it reads the hidden command. The filter has been completely bypassed because it simply didn't have the time or the computational power to see the trick.
The paper proves that you can always construct an AI and a set of these tricky prompts that no efficient filter can catch. To be able to catch the trick, the filter would have to be just as powerful and take as much time as the AI itself. And if your filter is that complex, well, you've just built another giant AI that you have to worry about aligning.
Okay, so filtering the input is a lost cause. But what about the other end? What if we just check the AI's answers? If it spits out something that's obviously harmful, we just block it before the user sees it.
The paper says that's also computationally intractable, which is a computer science term for practically impossible. A sufficiently smart, malicious AI wouldn't just write, "here is how to build a bomb." It could hide harmful instructions inside a seemingly innocent output.
For example, it could generate a 50-page, incredibly complex business plan, and buried deep inside the data in a way that's completely unnoticeable to a quick scan are subtle instructions or biases that would lead to a disastrous outcome. To find the hidden danger, you'd need another AI that was smart enough to analyze that entire business plan and all of its potential consequences.
Again, the checker needs to be as smart as the thing it's checking. This all leads to the paper's main, almost philosophical conclusion, which is right there in the title. It's impossible to separate intelligence from judgment.
What they mean by that is you can't have one system, the AI, be the raw intelligence, and then bolt on a separate, less powerful system to act as the judgment or safety layer. It doesn't work. The judgment, the ability to know right from wrong and act accordingly, has to be woven into the very fabric of the AI's intelligence.
So, this is what's known as an impossibility result. It doesn't give us a solution. Instead, it's a giant warning sign. It tells us that our current approach of trying to control powerful AI models from the outside with what are called black box methods is built on shaky ground.
It suggests that we can't just rely on creating better and better safety filters as a bandage. The challenge is much deeper. The research implies that the only real path forward is to figure out how to build AI systems that are fundamentally aligned with human values from the inside out.
And that is a much, much harder problem to solve. This paper uses these elegant, almost playful ideas from cryptography to show a very serious and very real limitation in our quest for safe AI. A fascinating and slightly terrifying piece of work. That's all the time we have for today. Thanks for tuning in to Daily Papers.